So, how to approach scenario analysis for critical raw materials? Climate scenarios are constructed in two major steps. First, the development of storylines of how the world develops, and next, the modeling of the climate consequences of those developments. In fact, these two elements, storylines and modeling, can be found in most scenario activities. They also make sense for critical raw materials scenarios. Critical raw materials are among the fastest growing resources. Their growth is mainly related to new technologies, including also renewable energy technologies. It's not easy to envisage the future for those. Will the technologies gain a good market share? Will the critical raw materials still be applied in those technologies? Will alternative products or systems be developed? Steel in construction is not likely to be replaced, but a rare earth element in a specific technology may conquer the world, or it may disappear altogether. When constructing scenarios for critical materials, we need to keep this in mind. When developing storylines for critical raw materials scenarios, a first distinction that is essential to make is that between demand and supply. Demand scenarios tell us about what consumers or other end users want, while supply scenarios will give information on how and by which technologies supply will be met. For both demand and supply, critical raw materials are complicated materials. When composing demand scenarios, we have to realize that end users have no demand for materials, but for products and services. Consumers want computers, mobile phones, or solar cells. Not indium, gallium, or cobalt. In fact, they usually won't even know there's indium, gallium, or cobalt in their devices. In the modeling step, it's therefore essential to use a bottom-up approach. First, establish future demand for products, then combine that with material content data related to those products. Supply scenarios have altogether different dynamics. Usually, in economic modeling, supply will match demand. For critical raw materials, supply has separate issues. For one, critical raw materials have often low productions, and it is not easy to scale that up on short notice. Secondly, critical raw materials are often byproducts of other metals, which implies their supply depends on the demand for the host material. For example, cobalt is by-produced with copper or nickel. If the demand for cobalt rises rapidly, but not for copper, scarcity is likely to occur. Also for that reason, critical raw materials have volatile markets. The highly fluctuating prices make it a risky endeavor to engage in mining them altogether. Thirdly, production of critical raw materials is in many cases limited to a few locations in the world. This makes their production vulnerable to geopolitical decisions around trade. When exploring the further future, therefore, it makes sense to include a black swan scenario, supposing some sort of a disaster, suddenly reducing mine production or trade. It can be useful to explore that. Will we still be able to meet demand? What will happen if we don't? Are there substitutes, alternative technologies? Can we provide from secondary production? This picture shows supply scenarios for cobalt. As you can see, the authors have looked at mine production per country. They have assumed production in Africa to stop altogether for a while in one of their three scenarios, perhaps as a result of assumed conflict mineral policies. This then will lead to a supply shortage. This could be an example of a black swan scenario. As we move towards a more sustainable supply of resources, secondary production is presenting itself as a solution. Accessing the urban mine, increasing reuse and recycling is also put on the table for critical raw materials. Presently, market volatility prevents large-scale investment in secondary production. Ultimately, we will have to rely on secondary production for an important share of our supply. How we will do that is not clear yet. It may be the subject for another supply scenario to explore.